So there's some more convergence tests that we have to do now. The first one we see is a little reminiscent of how we took limits. If you recall that in your head, maybe you can process that as that thing, and you'll see how this might be intuitive. Now you can take this as this, right? So it's the very same thing. The denominator of a denominator is a numerator, and you can do that, of course. So you can just write this as this. So this would cancel. So this would be 1 plus 3 by root k. And writing it in this form is very important because there is one very simple test that clears things for us, especially if it's diverging. So our guess might be that it's diverging. So if limit k approaches infinity, I'm sorry, I think this needs to be k. This cannot be a constant, I'm sorry. So this, just assume this is k and this is k as well. That's a typo, my bad. So this limit k approaches infinity, for this thing, as this approaches infinity, this factor would become 0. So it would be 1 plus 1, 1 divided by 1 plus 0, which is 1 divided by 1, which is 1. So the infinite term is approaching 1. As the infinite term is approaching 1, there's no way that if after infinity you keep on adding ones, that this would converge. So it's obviously the a diverging series by the divergence test. Okay. However, if the limit is not finite, it's 0, it's not a conclusive test for convergence. It's an inconclusive test. The divergence test is a conclusive test only for diverging series, so you have to keep that in mind. Now let's take the second one. This can use the ratio test. If you've manipulated factorials, you'll realize that this is pretty reminiscent of that. Let's just do that. So what you need to calculate is in the ratio test is a ratio of the n plus 1 k plus 1th term to the kth term. So you can call it the nth term. The variables are just there. So it is k plus 1 factorial divided by k factorial. So this gets inverted like this, k plus 1 factorial. Now k plus 1 factorial is of course k plus 1 into k factorial. As you know, k is an integer index, so this k cancels k, this is k plus 1. As k approaches infinity, rho approaches 0, or it is less than 1. And we remember from the ratio test, if this rho or whatever this ratio is less than 1, then there is convergence. So we use two very important tests in this.